So I'm going to talk quite a bit, actually, not really on not really on drug metabolism, but rather in general about drug-drug interaction, and with particular interest in herbal medicine. Previously, we have discussed about traditional medicine, the regulation, the safety, and the efficacy by our colleague, Dr. Nurhuda Mansur. So this is the continuation of that discussion. Dr. Nurhuda stopped on drug-drug interaction with particular interest on traditional medicine. So now I'm going to talk further on how and why drug-drug well, traditional medicine is not as safe as many people perceive it to be. So this discussion is going to be very basic, covering the basis of pharmacology as well as the basis of drug, what is drugs basically. So I hope you will get something out of it, and be careful later on what you take in, and what you perceive as safe is not really safe, actually. So drug-drug interaction is about the modification of one drug by another drug or substance. So it's basically, if you take one drug and you are taking another drug, what will happen to the existing drug, or what will happen to the both of the drug, whether it enhance the efficacy in terms of synergism, or it enhance the adverse effect, or it actually reducing the adverse effect or enhance the toxicity. So many things can happen if you take something together. So types of drug-drug interaction covering both pharmacodynamics, the effect of drug or the response of your body towards drug. Basically, if you're taking drugs for cardiovascular, what are the effects of the drug? And pharmacokinetics, what your body is doing to the drug, whether it is absorption, distribution, metabolism, whether your body can metabolize this drug efficiently or not, and excretion, whether you can excrete or eliminate the drug efficiently from your body, or it will be retained in your body for a longer time, in terms of drug-drug interaction. So drug-drug interaction is not necessarily harmful. It can be beneficial. You might have heard about combination of antibiotics, combination of anti-TB, or chemotherapeutic regimen. So chemotherapeutic regimen is actually based on drug-drug interaction between chemotherapeutics drug. So basically, it gives benefit to you in terms of reducing the amount of drug you are taking, because cancer drug is basically very potent and very toxic. So it reduces the toxicity or adverse effect of one drug, but taken together, this multiple drug will give the same effect, which is therapeutic value for this drug to kill your cancer cell. So it is not necessarily harmful, but harmful consequences can happen or can arise from drug-drug interaction as well. Sometimes drug-drug interaction can give no consequences. Well, it interact together, but it doesn't give any harmful or beneficial effect. It stays just there as interaction. So that's basically what will be covered, and that's basically the basis of drug-drug interaction. So this is just to show drug-drug interaction, but this is basically the harmful effect of it. It can induce or increase adverse effect, and it can induce loss of efficacy of one drug if taken together with other types of drug. But it can also reduce adverse effect. It can also increase efficacy of a drug when taken together, like in the story of cancer chemotherapeutics previously, as well as the antibiotics. So drug-drug interaction or drug interaction can happen between drug-drug. So the effect of drug when you are when taken together with concomitant drug with other types of drug food interaction happen when you take drug with a certain type of food that will enhance or reduce the effect of drug or the absorption, the metabolism, and so on when taken together with drug. Drug-herbal interaction, the effect of drug changed by concomitant administration of herbal medicine or traditional medicine. So this drug-food interaction and drug-herbs interaction sometimes it's interchanged, and it is somehow very fine line between the two, because herbal medicine, particularly in Malaysia, is not well regulated. Sometimes it is, sneakingly registered as food, and it is considered as food supposedly, but people has been taking it as drug in huge amount, and it can affect give many effect, wanted and unwanted effect, whether it's beneficial or it can be harmful is out of the question in this topic. But what we want to consider in this discussion is all about the drug food or drug herbs or drug-drug interaction. So the basis of drug, you might know what is drug, but I just want to lay out the same understanding here. Drug is any substance or product that is used or intended to be used to modify physiological system or pathological state for the benefit of the recipient. So if you take anything that will modify your physiological system, because essentially we are taking drug to modify something in our system, because our system is not working well. We are not well, we are sick, we are not well, something is not right in our system. We take drug to correct it or to modify it, to make it better. So if you take anything to modify or explore physiological system or pathological states for the benefit of yourself or recipient or patient, it is considered as drug. So anything, basically drug, registered drug, or any traditional medicine, registered or unregistered. For this topic, we will consider everything as drug or herbal medicine, although it's supposed to be food or registered as food or anything. So drug versus toxin. Drug is anything that causes an effect in the body. Toxin, of course, semua orang takut, is anything that causes an unwanted effect in the body. But all drug can be toxic. All drug can be toxin. Toxin sometimes can be a drug as well. So what is the difference between the two is only the dose that makes the poison. Even the innocuous thing that we consume every day, like water or oxygen, can be harmful if we take in high enough concentration that can harm us. So a substance can produce harmful effect associated with its toxic property if it reach high enough concentration. So drug or herbs or even food can produce toxic effect to your body if you are not careful, if you are taking it in high enough concentration. So sebab kita biasa dengar, so ini natural, cuma ulam, or something that we take as food for a very long time. Tapi when it is advertised, it can cure something. Contoh boleh reduce diabetes, So some people taking it in very high concentration. Some people taking it for every meal in huge amount. So it can reach high enough concentration that it can harm your body, or it can interact with existing drug or drug that you take together with this food. So to be safe, we must always think that all things are poison and nothing is without poison. Only the dose makes a thing, not poison. So only dose makes a thing, not poison. So how do you define the dose? So we don't know. To be on the safe side, whatever food supposed to be just food. You take food as it is, as human being. Berapa banyak kita makan as human being, food is food, ambil macam biasa. So it is safe. Tapi janganlah pula ambil like, a brain or belladonna as food. It's basically very toxic and it can harm you in such a little amount. So that's different. But what we talk about is just normal herbs that we can take every day, like pegaga, like tenggek burung, and so on. It's supposed to be safe. It's supposed to be not really affecting you and not really affecting whatever drug that you take. But for some reason, if you are overdoing it, you take it every meal, ambil banyak-banyak sampai, because you believe it can cure you. For some reason, it can harm you in a way that it can interact with your existing drug that you are taking. So drug, this is just, just to remind you, you might have known this previously. So it described as a substance that chemically describes a chemical substance, basically. Contoh biasa, drug that has been, available out there, easily available over the counter, and I believe everyone pernah makan, pernah ambil in their lifetime, and as still para-aminophenol, it's actually paracetamol. The active ingredient is paracetamol and acetyl para-aminophenol, and the brand name is available and known by many people. Contohnya, dia nak beli Panadol. Tak, yang warna biru. That's Panadol, tak warna biru. That's Euphamol. So macam kita recognize Colgate kan, subat gigi basically, but everyone panggil semua nak beli Colgate, padahal dia beli Darlie or dia beli other brand, but it's always as Colgate or Maggi. Semua benda Maggi kan, ramen ke apa ke, it's Maggi, but jenama Cintan, dia beli Maggi Cintan. Dah double pula brand kat situ, but it's basically the brand name that is known because Panadol is one of the largest and earliest brand for paracetamol. Was previously, I remember my late grandmother, she asked for ubat KK because previously the paracetamol is stamped with Kementerian Kesihatan and KK, and she always believed that only ubat KK works for her, but in reality it's just paracetamol like any other brand. So anyway, and this is important. I'm going to make public announcement, like public, sort of like peringatan. If you have and if you are taking drugs, you should always take note apa yang kita ambil, because sometimes it come to happen kita habis ke terhabis, terpaksa beli sendiri, ataupun you have some sort of reaction or something. It's better if you have notes on whatever that you are taking. Jangan nak ingat pil kecil-kecil warna merah, macam tu susah nak cari. Ada banyak pil warna merah or warna kuning or any bright color because it's easily recognized. Anyway, drug sources include natural sources and synthetic drugs. Sometimes semi-synthetic, macam estrogen and progesterone is semi-synthetic process from the isolated steroid from yam. So natural does not always mean good or safe, and synthetic does not always bad and not safe. So both are equally, you know, together, sama je. Tak kisah pun. Sometimes the early beginning of the discovery, the drug is coming from natural sources, and later on, companies learn how to synthesize the drug. Then it is fully synthetic. So, ya, ini mungkin dah pernah jumpa dan dah pernah diulang-ulang sebelum ni. Ada juga di hadapan, sekarang ramai orang bercucuk tanam. You can find this kat kampung-kampung dan sebagainya. But this is always my favorite. Tapi saya tanam berkali-kali mati juga, tak tahu kenapa, tak berjodoh dengan saya. So this is Catharanthus roseus, kementing Cina, if I'm not mistaken. So Catharanthus roseus produced one of the earlier chemotherapeutic drugs, vincristine and vinblastine. And this drug is very potent for many types of cancer, particularly blood type of cancer. But jangan nak cari, sekarang dah banyak kan kat depan rumah, jadi boleh ke rebus. Ada juga, saya pernah ditanya, because I'm quite active in social media, and they ask, oh, this produce chemotherapeutic drug, boleh tak saya makan je bunga ke daun ke buat ulam ke? Boleh lah kalau tahan, dia pahit banyak ketah. But that's not the point. The point is this plant actually only produce minute amount, very little amount of vincristine and vinblastine, and this compound is not even available naturally. Kita kena like link together the compound synthetically. So don't even try to buat ulam pokok ni to cure your cancer. Just go to the hospital and ask for, opinion of the respected doctors. And this is Podophyllum peltatum, that etoposide and teniposide coming from doxorubicin, one of because doxorubicin is always in red color, very bright, very vibrant. It's coming from fungus. And last example, but not least, I'm not really showing, this is LSD, acetic acid. It's not coming from the gandum, tak, bukan gandum yang menghasilkan LSD, but it's actually the black fungus covering the plant. So Claviceps purpurea, so ergo fungus. So this you can see yang macam stem is not actually a stem or pelekat ke sticker. This is real. This is real picture of LSD. Actually LSD itu tak macam ni. It's just kita panggil dia acid. Ada orang panggil dia acid, and nama panggilan dia pun acid. Because LSD is soluble in water, they just blot the paper with this LSD, and if you put it on your tongue, the LSD will dissolve and do whatever it is going to do in your system just by putting the sticker on your tongue. So kalau ada, saya tak bisa, LSD agak mahal, but it's a recreational drug available. Sekarang banyak designer stuff coming from LSD. Kalau anak-anak ke, your kids, your cousin ke, your adik-beradik, budak-budak sekolah sometimes bawa balik stiker ke apa, you better check, because it can be this stuff. Anyway, so we know now, and we set the background of what is a drug. So now come to the topic on how the drug coming into your body and work what is supposed to be working on. So how will any drug, a bitter liquid, a pill that get from your mouth coming to the pain of to the intended target. So it's basically the pillars of pharmacology, pharmacokinetics and pharmacodynamics. So pharmacokinetics concerned about what the body does to the drug. So it concerns about administration, absorption, distribution, metabolism, and excretion. So it concerns about the fate of the drug inside your body. How the drug is being absorbed, how the drug is being distributed, how the drug is being metabolized and excreted out from your body. Pharmacodynamics is about what the drugs do to the body. So if the drug is supposed to kill your pain, it's supposed to, the pharmacodynamic is all about how the drug or the amount of the drug that kill the pain away. So it's the study about the actions of drug on the target organ. So when talking about drug-drug interaction, you always have to understand about pharmacokinetics and pharmacodynamics of drugs and whatever that you are taking in, whether drugs or herbs or food. So because everything that you eat will be absorbed, will be distributed, will be metabolized, and will be excreted out. So pharmacokinetics and pharmacodynamics help to explain the relationship between the dose and the response, and it helps to explain how drug-drug interaction can happen, or how drug or traditional medicine can happen. So when you take a drug, it is going to be absorbed and taken into the body. So absorption is all about how and why the drug is absorbed and taken into the body from your mouth. So everything yang kita makan, kita akan absorb. Okay? Kalau tak boleh absorb, kita keluarkan balik, sama ada going through the urine or going to the feces. Whatever that we take in will be distributed in our system, and drug will be, or whatever that you're eating, and in this case, kita cakap pasal drug. Some drugs are prodrugs, inactive drugs. So metabolism will activate the drug or will change the drug so it can be excreted out. So excretion is the act of removing the drug from the body. So this is actually the journey of a drug inside your body, from your mouth to your urine or to your feces. So along the way, interaction can happen, because along the way, we don't only taking in drugs. We take multiple drugs. Polypharmacy, we take multiple drugs. We take herbs together with drugs. We take food together with drugs. So in any point of this, interaction can happen. So let's talk about absorption first. So kita cakap pasal absorption by oral, drug taken by oral. So bila kita makan, drug tu akan masuk mulut and then going through your gastrointestinal tract, your esophagus, your stomach, your intestine, small intestine, and going through your liver and so on. Nanti pergi ke urine and feces to be eliminated. So absorption actually happen from the moment it goes into your mouth and to stomach, to small intestine, to the liver, and then to and so on. So absorption happen along this gastrointestinal tract. So the very basic and major aspect of absorption is all about pH, because most drug will be absorbed by diffusion, by diffusion, passive diffusion. So it's basically based on whether this drug is polar or non-polar. So only non-polar compound or non-ionized compound can pass through your lipid, phospholipid barrier, your cell, basically. So pH plays important aspect of drugs or any compound that you are taking in. So different drug has different absorption rate in different part of your gastrointestinal tract, because along your gastrointestinal tract, you can see it has different pH. Your mouth is neutral to slightly alkaline to acidic, slightly just. So your stomach is very acidic, 1 to 5 pH 1 to 5. So your small intestine is neutral to slightly alkaline. So different type of drug, because different drug has different characteristic and different pKa value, which is the characteristic, the chemical characteristic of the drug itself. So this drug is absorbed at different part of your gastrointestinal tract. So contohnya, saya pernah jumpa dulu masa kecil, saya ingat lagi, I remember meeting this old grandmother. Saya tanya dia, ni tak pernah kena you know, sentil tembakau tu kan, because you know, you chewing the tembakau and it's endless. It's like you have to like every time in your mouth. Kenapa tak telan je? Rupanya that grandmother is actually much more clever than me, because nicotine, the major component that you get from tobacco, you want to get from tobacco, this component is still at 5% more, but you want to get from tobacco, it's a nicotine, it's a wheat base, so it has better absorption in the mouth than GI tract. Kalau kita telan, nicotine will not be absorbed efficiently into your system. But if you like chewing tobacco in your mouth, it will be the nicotine will be absorbed faster and efficient in your mouth. So that's basically absorption. Tapi nenek tu pandai. Tapi orang sampai sekarang dia ada like very so many myths based on absorption of drug or substance or even food. This is something that I get from just googling around about myths. Ini dah jumpa bertahun-tahun dan berkali-kali, and every year we have to talk about this. So they believe that kalau minum air sejuk dengan lemak tu akan bergumpal dalam perut and not going to be absorbed. Macam tu kita tak payah exercise, every time makan cheese lele ke apa ke, steak ke, whatever that very oily, berlemak-lemak, kita minum je air sejuk, tak payah nak exercise. So kita takkan jadi gemuk, because lemak is not going to be absorbed. Yes, lemak is not going to be absorbed in our body, which is very wrong, because we can regulate our thermometer. Kita ada thermometer sendiri dalam tubuh kita, satu, and absorption does not really involve temperature actually. So it doesn't matter minum air sejuk, minum air panas, it will be absorbed and you eat anyway. So ini jamu, certain types of jamu, tak tahu kenapa dia nak makan, but anyway, kalau haid tak boleh makan jamu sekalipun, dia tak akan meresap kononnya lah. But eat in any way, you eat something, boleh je meresap, boleh je absorb. Okay, kalau macam tu, kalau makan ketika haid, kita tak absorb kan. Uruslah orang haid lama-lama tu. You know, tak tahulah. Anyway, so absorption interaction is basically more on food, and ada juga certain types of drug, but you can look for it kebanyakannya because of the bulky fibers and so on. But ini saya nak cakap because mungkin this is senna, the first one yang with yellow flowers is senna. We don't really find senna in Malaysia, but it's always available as ubat mengurangkan berat badan, because it induces actually diarrhea, peristalsis movement of your intestine. So it basically reducing the absorption of your of any drugs that you eat or any nutrient that you're supposed to absorb, because you basically having diarrhea most of the time because you are taking senna. And aloe vera, ada juga sekarang ramai orang jual aloe vera, giant aloe vera, and guar gum from guar bean. So this is complex carbohydrate that will actually sama juga macam senna, and it actually sebenarnya glucomannan. It burden your colon, and whatever that you eat will not be in there, and kita pass our stool quite fast than normal. Itu je dia punya function, but it reduce some nutrients as well as drug that you are taking basically. So the last one is okra, lettuce finger, bendy. This is not so much about, yes, dia ada mucilage, dia ada mucin, but selalunya kita tak makan banyak, cuma as ulam or in gulai or as normal diet, but it has been advertised. It can reduce blood pressure, it can reduce diabetes. So people have been taking it regularly and religiously, but this can be dangerous, especially for patients who are taking acarbose, who are taking blood, who are taking alpha glucosidase inhibitor, such as acarbose, because the mucin in okra actually working similar as acarbose. So it's a complex sugar, complex carbohydrate that inhibit alpha glucosidase as well. So you can be hypoglycemic because of taking okra. Tapi kalau ambil dua biji, dua batang tu, or makan kat dalam gula, it doesn't affect you that much. So the next one is distribution, how drug is distributed in your body. So basically, this is well described, and this is well noted in drug-drug interaction. The most common issues is warfarin and salicylic acid. So it displaces warfarin from protein binding, and you can get warfarin excessively than intended, than the intention. So you bleed out, or you can have bleeding. But salicylic acid, aspirin is not common, especially in Malaysia, but some adulterated herbal preparation or some herbal preparation are intended to have salicylic acid, salicylate in its preparation. Contohnya macam apa tu, penahan sakit, minyak angin. Ada pula orang suruh minum minyak angin tu. Pening kepala lah juga nak mengira dosnya. Macam tak payahlah minum. Kalau kata dia minyak angin, sapu je lah kat luar kan. Kenapa pula nak minum? Tapi ada juga yang minum. Dan ada pula sekarang jual essential oil, because it's basically menthol, salicylic, and a mixture of it. Diminum juga, tak tahu lah kenapa, but just if you're taking certain cardiovascular drug, warfarin and so on, whatever that you want to take, herbal medicine or whatever, talk to your doctor and discuss with your pharmacist what you want to take. Don't just simply ambil because of people told you so. So last but not least is about metabolism. Metabolism can happen along the way in the gastrointestinal tract, but basically it happens in majority in your liver. So whatever that we consume will go into the gastrointestinal tract first and absorb to the liver. Okay, absorb to the liver through the portal vein. Okay, this is good because kalau tak, kita makan terus masuk blood vessel, dah lama dah kita punya blood vessel clog with all sorts of things that we are taking seriously, cheese ayam, cheese lele, whatever, semua letak cheese sekarang, semualah. Kalau tak ada our liver to metabolize things first, to sort things first, to unravel everything that the complex thing, tahap apa yang kita makan, I don't know what will happen to our blood circulation system and what goes into that. Dengan apa yang berhari-hari, setiap hari kita makan, I can't even imagine what will happen without our liver. So thankfully, so that's why kesian dekat kita punya liver. Eat moderately, jangan ambil macam-macam yang tak perlu, all the supplement, all the herbal traditional medicine yang tak tahu, mungkin dia tak traditional pun, adulterated and so on. So tak perlu sebenarnya, because it will only burden your liver and kidney to eliminate all things out. So this is basically what I have described previously. Whatever coming into your gastrointestinal tract will be absorbed and then will be transported into the portal vein to your liver, and your liver will sort and metabolize and sort of like strain whatever that is needed, unwanted, toxic, and change it to untoxic compound before it gets into your systemic circulation. So, however, when we are taking some drugs that is beneficial and suppose that we need it, this drug gets metabolized as well. So metabolism basically will inactivate the drug and will enable the drug to be excreted out from our system. So partially this drug will be metabolized. So, but that's okay because the drug dosage has been calculated and taking this into account. So can you imagine if we take something else that this drug, this system that induce metabolism higher than metabolism of the drug higher than intended, or reducing the metabolism of the drug lower than intended, it will change the bioavailability or the availability of the drug that's supposed to be this sort of amount or concentration in our body. So this can cause harm in itself, in the drug itself. And kalau ada multiple, kita ambil herbal medicine, banyak, compound, whatever compound that we are taking in, we don't know whether this drug will interact with each other or this compound will interact with each other or with the drug that we are taking. Metabolism basically enable whatever that we are that we took to be excreted out. Okay, so it changed the compound to be much more polar and to enable the compound to be excreted out by our kidney in urine, or to be incorporated into bile and being excreted out in feces. So, ni ada satu lagi mitos juga. Saya tak tahu. It has been around for years and years and years, and it doesn't seem to, subsided. Setiap tahun mesti ada orang lain yang akan coming out with this myth. So Panadol kalau makan dia akan duduk dan kekal dalam badan kita selama 5 tahun. So whatever, basically paracetamol, if you consume paracetamol, they say it will be retained in our body for 5 years. So kalau macam ni, if this is true, then Panadol is not a brand name that is, here for a very long time. Kita makan sebiji je, we take one for 5 years, we don't get sick, we don't get any painful sensation at all. So it's not true basically. It's like what you eat. you get hungry, then you have to eat again. So basically, it's the same thing. Whatever that you consume, it will be metabolized, it will be excreted out, and you have to take another drug again. So it won't be retained in your body, except if you are taking certain types of heavy metal like mercury or silver. Ada pula yang orang pakai silver nitrate to cure any ailment in what they have and refuse to take a simple paracetamol. I don't know their reason, but that happened, and ada juga case yang macam tu. But anyway, this is myth. Tak payah suruh Dr. Malina yang jauh dekat UK to explain to you. I can explain to you. Anyway, paracetamol is only retained in your body for 6 to 12 hours. So don't worry to take in paracetamol. It won't be retained in your body for very long, half a day. Lepas tu sakit balik. Bila dah sakit balik tu meaning that there's no more paracetamol in your body anymore and you need to take another one. So that's basically metabolism. And excretion is all about drug being excreted out. So it's supposed to be, drug is calculated on the dosage and intended half-life to be retained in our body. So that kalau baca dekat belakang, if you read on the leaflet or at the back of your paracetamol pack, you will have some instruction to take 2 to 4 tablets every 6 hours because it's being excreted out in your body, from your body by that time. So metabolism and excretion is something that, together. So metabolism is helping the drug, or metabolism change the drug and enable the drug to be excreted out. So that's basically it. This is about paracetamol. I'm going to use paracetamol again and again as example. So paracetamol will be metabolized whether it is the addition of glucuronide, sulfate, or glutathione conjugation. So this is safe compound and much more polar than paracetamol itself to be easily excreted out in your urine. So don't worry, it will be out from your system anyway. So those are the examples of enzyme in your liver that help you to do all these things, to change the compound and enable the compound to be much more polar and excreted out and soluble in urine, much more soluble in water in urine, and excreted out from your body. So why do we metabolize drug? This is a summary. Why do we metabolize drug? Because excretion is easiest when a compound is water soluble. So metabolism makes drugs more water soluble. So no brainer in that. How do we metabolize drugs? There are two phases, not two phases. Drug does not necessarily have to go through these two phases. Some drugs like paracetamol, it can straight away goes to phase 2 metabolism. So these two cluster of enzymes help you to metabolize and to change the compound to become basically much more polar. So this compound can be solubilized in water, can be soluble in water and bile, so that it can be carried out by water to be excreted out as urine, and in bile to be excreted out in feces. So what are the outcomes of metabolism? Basically, from active metabolite to inactive metabolite, or inactive metabolite to active metabolite. Macam tamoxifen to endoxifen is inactive to active metabolite. toxic to non-toxic or non-toxic to toxic in terms of paracetamol, the other toxic compound. But don't worry, because these compounds will straight away to conjugated with glutathione in your liver to become this non-toxic compound and excreted out in your urine. So, and change, the third outcomes is to change lipophilic drug to much more water-soluble drug. So basically, cytochrome P450 enzyme, the enzyme that I'm working on, basically in day-to-day basis is to just, it's actually an oxidoreductase, just to add hydroxyl oxygen to the drug so that it becomes more polar. So phase 1 mainly use cytochrome P450. So every time I talk about cytochrome P450, is about this cluster of enzymes that, you know, add OH and oxygen to a compound. Okay, so this is this enzyme is basically membrane-bound protein. It is available on inside your liver, in the hepatocyte, the liver cell, on the endoplasmic reticulum membrane. So unlike orang tanya saya, because this is what I'm working on basically, kenapa nak susah nak express this enzyme, nak buat molecular model, you have to, you know, do molecular system, recombinant system, then buat pula whatever model susah-susah lah nak buat semua ni. You can just buy it, like you buy glycosidase enzyme, you buy hydrogenase enzyme, and so on. Well, we can't really buy this enzyme ready-made because this enzyme work like this. It's supposed to be available as a clusters like this on the membrane, and then, well, then it is working. It is working together with this cytochrome P450 working together with cytochrome B5 and perhaps the 2B6 together as, you know, a cluster of component so that it will work to metabolize whatever that you want them to metabolize. So it is not available as a single enzyme. Kita kena isolate dia from liver basically, or you have to engineer cell, bacteria, or whatever to produce this as a cluster and isolate these clusters of enzyme on a membrane together. Dia tak boleh cerai-cerai. Yang penting kerjasama, bersatu kita teguh macam tu. So this enzyme is not really available to buy as a system by itself. So that's why you cannot really see. Kenapa tak buat je like AC of this ceko dengan paracetamol or Halil with some other drugs. It's not easy to do that because the enzyme itself is not really readily available. And animal model like rats, mouse, and human, of course, human have the enzyme, but you have to kill the human or you have to extract the liver of a human being in order to get this enzyme working. But rats, mouse, rabbit, and so on, they have different variant of enzyme, cytochrome P450 enzyme, and it's not really compatible with whatever human have. So it might give you slightly different result. So drug-drug interactions is not really something that easily to do in that basis. So this is basically about cytochrome P450. Ada banyak CYP3, CYP2, and so on. And it's not only working to metabolize xenobiotics, whatever that you are consume, but cytochrome P450 as well metabolize endogenous compound, like in the case of you producing your steroid hormone, estrogen, progesterone, testosterone is all about cytochrome P450, but that's another cluster of enzyme, cytochrome P450 enzyme. So this enzyme, kalau dekat sekolah dulu kita belajar, we learn about enzyme, it's lock and key, one enzyme, one substrate, but unfortunately for cytochrome P450, it's about one enzyme, multiple drug. Many types of substrate or drug can bind and can be metabolized by CYP enzyme. So that's why one cytochrome P450, one type of cytochrome P450 can have multiple substrate coming from your paracetamol, coming from your ulam, coming from your herbs and so on. It can actually affect the enzyme together. So kalau dia spesifik like paracetamol saja, then it doesn't matter, you eat whatever that you want to eat. But this enzyme is promiscuous, it can metabolize many substrate, so it can be affected by many substrate. That's the reason why metabolism-based interaction might happen. So let's not talk about drug. Kita cakap pasal something yang very fun a bit. Coffee. I just had my coffee on Monday morning to make me awake. Anyway, caffeine basically relying on cytochrome P450 enzyme to metabolize caffeine into something that is much more easier for your system to eliminate. So contohnya caffeine will be metabolized to theophylline, paraxanthin, and theobromine by CYP1A2. And some people ask, okay, you might ask as well, kenapa, why some people like me can have double shot espresso, but I can just have my beauty sleep right away without any problem at all. But another person had one latte in the morning, and at night, the following night, she or he cannot even close their eyes and have their sleep. It's because caffeine makes you awake and alert. Okay, so why it seems that people like me is lesser affected by caffeine and other people is much more affected by caffeine? One of the reasons is because this metabolic enzyme, the CYP1A2, it's not similar from, I have a different variant of CYP1A2. It's still CYP1A2, but a different variant. And other people might have different variants. So there are people who are called as rapid metabolizer. So people like me who can just fall asleep after having double shot espresso is actually and probably an ultra rapid metabolizer. I can metabolize caffeine very efficiently. Okay, so minum je caffeine, I take the caffeine, double shot espresso, and it rapidly metabolized to and available already in my urine. Okay, by 1 hour probably. So the caffeine doesn't affect my system, while the other person who can't even sleep after having single latte in the morning, they are probably for metabolizer. They break down caffeine rather slowly, much more slower than the intermediate metabolizer. So this person will still have caffeine inside your body even after 12 hours taking a single shot of latte. Okay, so that's the difference. So can you imagine if you have this and apply this in terms of drug and in terms of herbs, you might have you might know, but you cannot know which type of variant that you have, and you might be different than other people. So I think it's best to avoid from now on. If daripada memandai-mandai nak cakap dekat orang tu, kau ada diabetes, boleh lah ambil this herb, aku ambil okey je. Orang lain mungkin ambil and cause something bad effect to them. So it's different from one to another in terms of SIPs. So phase 2 metabolism, seperti saya cakap yang tu kemudian sikit tetaplah. Phase 2 metabolism is actually about similar like cytochrome P450, but their function is not oxidoreductase, not adding hydroxyl or oxygen, but the addition of conjugate like glucuronide, sulfate, glutathione to a compound, so that this compound will be much more polar than the initial compound. So this sama juga macam it is similar like sister, one enzyme, multiple substrate, one enzyme, multiple substrate. So in paracetamol metabolism, the blue one are actually involved in phase 2 metabolism, glucuronization, sulfation, and addition of glutathione conjugation. And the red arrow is actually phase 1 metabolism that produce NAQ1, which actually quite toxic, but undergoing the phase 2 metabolism, it can be converted directly to the non-toxic substance and can be extracted out from your body. So basically, enzyme induction and enzyme inhibition is similar like what we talked about previously. Any drugs or any substance can induce drug metabolism and can reduce drug metabolism by means of enzyme induction and enzyme inhibition. So it basically affected the enzyme itself in terms of drug-drug interaction in the metabolism related drug-drug interaction. Okay, so it is an important concept to understand drug interaction secondary to changes in the enzyme activity. So you bear in mind that the interaction happen based on the enzyme induction and enzyme inhibition. So why this is important? Because CYP enzyme, particularly one cluster of enzymes, CYP3A, responsible for the metabolism of 50% of drugs. So these drugs needs to be, it has been calculated on how long it should be inside your system and how much it should be inside your system. But if you change this by taking other types of drugs or some herbs or some food that affected the enzyme, it induced or it reduced the enzyme activity, it will change not just the outcome of the drug, it can affect the adverse effect and toxicity that the drug might come and bring forward to you. So drug interaction at enzyme activity level is pretty much unexpected because first, we don't know there are many things that can interact with the enzyme first, and we don't know which type and which variant of enzyme that you have. You are probably rapid metabolizer. The drug is commonly, very low in the system and anyway. If you inhibit quite a bit, it's still in the safe amount. But if you are a slow metabolizer, you might have drug already retained in your body, and you further burden the enzyme system with whatever that you are taking, and you further delay the excretion or the elimination of the drug from your body further. Just for example, by using paracetamol metabolism as well. So ethanol or alcohol increase CYP2E1 protein stability. So the protein that convert paracetamol to NAQ1 is actually CYP2E1. If this protein is stable and this protein is induced by alcohol, it will increase NAQ1 concentration in your body. Suppose you only have you have 95% of these conjugates and only 5% of these. But if you induce and you have high amount of CYP2E1 enzyme active, you might have more than 5%, which burden your system and which you will have this toxic compound much more than your body could handle. Tapi kita selalu macam, ini just example, right? It won't happen to us because most of us are actually in Malaysia. We don't have this culture of consuming alcohol, and many of us are Muslim, so we don't consume alcohol, right? So you are wrong. Dikenal nih, this is tapai, okay? This is ongoing debate and ongoing, like, I don't know, it's endless to say that tapai is actually contain volume per volume alcohol, which is quite high. And the problem is tapai is not standardized or regulated. Okay? It's not standardized and regulated. It depends on the maker of the tapai, and it depends on the starter culture, the ragi that used to make tapai. So basically, tapai can have 3 to 5% volume per volume of alcohol by 3 days of fermentation. So normally, 3 days of fermentation, 3 to 5% volume per volume. So if in 5 to 7 days of fermentation, it can reach 10 to 15% volume per volume of alcohol in tapai. So by comparison, it doesn't seem high, right? But by comparison, beer actually contains about 7-8% volume per volume alcohol, and wine, regular wine, can have about 10 to 15% volume per volume of alcohol. Okay, so you can imagine your tapai is actually equivalent to that alcohol. I'm not going to talk about whether it's halal or haram or anything else. This is just a matter of stating the fact that no safe amount of alcohol is safe. Okay, and for pregnant, especially for pregnant lady, no amount of alcohol is safe to avoid miscarriage and fetal alcohol syndrome. So if you can, please avoid tapai at all costs. Anyway, so this has been covered previously. So we have substrate, inducer, and inhibitor. We have talked about it. Substrate is the drug metabolized by cytochrome B450 or the metabolic enzyme. Inducer is the drug that enhances the activity. Inhibitor, drugs that induce or compound that reduce the activity of cytochrome P450. So put that in mind. So anything can be a substrate, anything can be inducer, anything can be inhibitor based on the combination of what you are taking at one time. So grapefruit juice is one of the most known CYP3A4 inhibitor. So if you take a certain drug together with grapefruit juice, it can induce drug level toxicity because it reduces enzyme activity and reduces drug clearance. St. John wort, probably famous in this Asian continent. It is actually CYP3A4 inducer. It can induce enzyme activity and drug clearance, so you have lesser drug efficacy. So herbal medicine it's unrecognized dangers. It's not really a danger if you know what to do, but it is something that people deem as safe. Tak apa, ambil je ubat doktor, ambil je herbal medicine. It won't cause you any harm, but it is not true actually, because it is known to cause interaction with prescribed drug, and recorded in notes occasionally at 4%. Because the problem is this herb drug interaction is not well documented, and it is not well studied, and it is not well known, especially for drug or for compound that coming from us, the Asian country. So St. John Wood's, the enzyme inducer, there are many reports out there that can induce rejection, that can induce bleeding, that can induce cardiovascular drug interaction, and so on. So you can read about it, and you can just Google about it. So Google grapefruit interaction, it induce and affect many metabolic enzymes because of the furanocoumarin. But not only, I believe it's not only just the furanocoumarin in citrus fruit. It basically many other polyphenol and other types of compound that contain in the grapefruit juice. So there are studies. I don't know whether I include this as well. The grape juice fruit is other report basically from hospital, whether this can happen when you take in normal, normal grapefruit juice in the morning, and then not occasionally, it can happen by taking just that as well to some people. So there are possibility of manifestation of interaction, but it is hard or difficult to identify because there are a large number of herbal products that are easily available, and this herbal product is not really regulated, as in it has no standardized amount of compound, it has no standardized ingredients and so on. Just mix and match everything, anything that is available, and based on the prescriber that giving the herbal product, is basically consists of multiple constituents of various pharmacological activities. Ada yang banyak, ada yang sedikit. There are a lot of this compound, a lot of that compound as well, and we don't know which one actually affect the metabolic system as a whole. And particularly, there's lack of data on the herbs-drug interaction as well, because it's not easy and it's not really reported. So you can't really have extensive report on drug-drug interaction. And common problem is herbal product labels does not deliver authentic or necessary information. In Malaysia, for instance, you have to only put like foliage, daun, berapa banyak, how much you put in the extract from the leaf, the stem, and so on. But it does not quantify basically how many or how much constituent inside the herbs itself. So we don't know actually. Even we don't know whether the real herbs is the herbs used in the herbal preparation is authenticated or not. So basically, as a conclusion, drug-herbs interaction can happen in various points of herbs of drug journey inside your body. It can affect on how drugs is absorbed, distributed, metabolized, or it can affect the outcomes of the drug itself. So, and particularly what's important is drug herbs can interact in metabolism state. It can interact or reduce the efficacy of the enzyme that metabolize drug that will help you to eliminate this drug from your body. This is another example. It doesn't really inhibit or induce, but it's actually inducing the translation of the gene translation related to this enzyme as well. So this is Wuweji, one of the Chinese herbs, traditional Chinese herbs. Many other example, grapefruit, black pepper, garlic. So be careful, especially those working on natural product, phytochemistry, and so on. Don't just advocate. We want to advertise our work, our local herbs and so on, but just be careful in order not to overselling it and can cause this problem later on. So notable compound, because not many compound, they can say that these andrographite, andrographis honeyclapper, contohnya the Phodobini can affect cardiovascular drug, but we don't know actually what's inside the andrographis paniculata that affect the cardiovascular effect of the drug itself. Kita tak tahu whether it's andrographite or some other things inside the extract. Furanocoumarin, contohnya in grape juice has been studied, but there's mixed results on it. It's not about the furanocoumarin, it's about the polyphenol and so on. But furanocoumarin has been shown as a suicide substrate for cytochrome, many cytochrome 450 enzyme. Ginkgolide from ginkgo. So be careful if you take ginkgo extract, kalau nak bagi cepat kita punya memory cekap dan tangkas, tapi liver rosak pula, susah. Hypochlorine from St. John Woods. Garlic banyak. It notoriously suppress CYP2E1 enzyme. So be careful nak makan garlic dalam apa in your food, goreng ke tak apa, no problem, but do not go and buat garlic as ulam, makan whatever in every meal, in every buat product, every time if you take in some drugs, because even paracetamol can be affected by garlic. Wu Weiji tadi because of schisandrol, and schisandrins, itu saya sebut. Silibin from silymarin and chrysin involved in the increased activity of UGT1A1, one of the phase 2 metabolism. So, oh yes, this is grapefruit medication interaction. I always say that it is only in excess amount if you are taking. It is true for many types of herbs, but for grape juice you can see on even taking it on regular basis or just a day before, or 1 liter, 0.5 liter is not much, but it can affect some drugs, and it can give you harmful effect as well. So these are another example: ginkgo, garlic, kava, danshan, anyway, licorice, and so on. These are many other examples as well. Golden seal green tea. I remember my sisters they are taking green tea, nak kurus kodonnya, but they have quite a bit of problem with the metabolic enzyme in terms of hormone producing enzyme being shut down. Anyway, as a conclusion, because of the global increase of the use of herbal product, we need to strengthen our strategy, not only to advertise our local herbs as alternative medication or source of drugs, but we need to study and continue to do some research on how this herbal extract herbs can actually affect or interact with existing drug as well. So this is basically what I'm doing and what I plan to do in the lab. We actually do some study on molecular modeling to help us to study drug interaction or drug-host interaction easier with some clones, cell clones, and with the help of probably high-end instrument that we have now, thank you, we can actually bring forward our research to the next level, hopefully. So with that, thank you.
Okay, thank you, Dr. Normala, for a very interesting and informative lecture today, this morning. Now we know that we don't have to take paracetamol for for every 5 years, okay? And then we know also that some herbal medicine can interact with some of existing drugs that we intake. Now I open for any question and answer from the attendees. Okay, I guess that there is no questions. Ada. Salam Dr. Normala thank you for the presentation regarding the drug herbal interaction, how the double-edged sword properties possessed by the herbal. If you may comment on that.
Yes, I'm not saying. I'm not saying that herbs is all bad. It's not. It's just now we don't know, and we have very little information on how this drug can interact with herbs. So what we should do is actually not abandon the herbs altogether, but we should and we must and we should study our herbs not only for the benefit of it, but also how it can interact or how it can be beneficial in terms of its interaction with other types of drugs. Okay, so to me, we shouldn't abandon. Okay, we shouldn't abandon herbs or traditional medicine just because it can cause harmful effect, but we should be proactive and study more on not just on how to develop this to be a drug, but to develop this to be safe, to be practiced as alternative medicine.
One question, Dr. Normala, jika saya tak silap dengar, you said that paracetamol can keep in the body for 5 years. Can you show me the article that mentioned that?
Tak ada artikel, itu semua myth. Myth by circulating in our society. I've been listening and I've been getting this question over and over and over again for many years. I thought it will be subsided after a few years, but masih ada orang percaya. It's not true, but ada orang percaya. Okay, ada orang percaya. It's not true, but ada orang percaya this myth even now.
Okay, if we don't have any questions anymore, we shall end our webinar for today. Thank you for participating in this research webinar series. See you in the next round. Okay, Assalamualaikum.
Okay, thank you so much, everyone.